when it's factored out, you have to think about what it would be if you multiplied it out. And the way you do that is just look at the individual exponents. So this is first degree. We have a third, we have a second, and then this is also first. You just add those up. Your first term, if you multiplied it out, would be x to the 7th. Okay, so it is a 7th degree. So that tells me what the ends of my graphs are doing. If it is odd, remember they go in opposite directions. Okay, it's odd and positive, so you should in your mind just be envisioning like the cubic function. So I know the right side is somehow going up at the end, and the left side is going down. Don't really know what's happening at the x-axis yet, but got that right. Some lovely pieces coming together here. Okay. Multiplicity is the next thing that's going to matter a lot. I see two different multiplicities. I see a cubic here, so that's odd multiplicity. And then I see a squared, which is even multiplicity. The ones with ones, that just means it crosses the x-axis. It doesn't do anything fancy. It just goes through that point. The odd ones, that's where you get like the point of inflection, like the cubic graph. That's what it's going to look like around that 0. What does it do at even? You guys remember?
Bounces.
Bounces. Good. Yeah, it's going to bounce off the x-axis. So this first one, x minus 3, that'd be at x equals 3. I know that I'm going to have that sort of thing happening at that 0, right? I'm going to have that inflection point. Then at negative 2, it's going to have to bounce. Well, I got to figure out which side I'm on with that to know where it's going to bounce. So I'm going to go through the ones that just have multiplicity of 1. So like at the end here, it would cross. Oh, there's negative 2, so it's going to have to bounce. Cross. And then I can kind of come back up. I've got a weird shape going on right here, but guys, that's it. Right now, you do not know enough to have any idea how high those like maximums are going or how low the minimums are going. You'll learn things eventually this year where you will. But right now, when I say sketch, that's it. I'm looking for the end behavior. Like figure out if there's any multiplicity. I need the x-intercepts. And I need the y-intercept. It worked out very easily on this one because you had 0, 0 as an x and a y-intercept. But that's all I'm talking about when I say sketch. So give me some feedback here. Thumbs up, I'm feeling good about it. Kind of okay, or oh my goodness, I have no idea what just happened. I just want to know kind of where we are. Okay. All right. Let's do one more real quick just to make sure we've got it. So same idea. Okay, so sketch the graph again. And yes, you will have to actually find your y-intercept this time. Give me a minute to try. Once you're ready, chat with your neighbor. Okay, you don't need to take marks on your y-axis to plot y-intercept. You just put a dot, label it, and that is where that is. All right, guys, let me put the answer up here. So I got my x-intercepts. My y-intercept, what'd you guys get for your y-intercept?
36.
36, yeah, so I'm just gonna go, all right, there's 36, looks great. Okay, the beauty of sketching graphs, you don't need it to be perfect. What?
Interesting.
Oh, okay. Let me change your attendance real quick. All right, guys, hold on. All right, so we've got these points. What about the degree, guys? What is the degree of this one? 6, yeah. So it's 6 and positive. So even and positive, both ends are going to be going up. So I know something there, and then I can start looking at multiplicity. So this one's even, so I know it's going to come down and bounce. And then we got to hit that y-intercept. At 1 is cubic, so we have like a point of inflection, which is hard to draw. I struggle more with drawing them that direction too than the other way. So on a test, if you're ever like, hey, that doesn't look like it, just label for me, be like, that's a point of inflection. Because then I know you know, but the drawing just didn't go quite as planned, okay? Were you at the...
I was looking at you.
Okay. out your graph. Were we better on this one, guys? Feeling a little bit better about things? Okay. All right. Let's get to our notes. So go ahead, whatever you're taking notes on. Out. It's a heavy set. Are we okay?
Yeah.
Okay. Okay, guys, first thing we're going to talk about is finding possible rational roots. This is just the list of P over Q values. Do you guys remember your P over Q list from last year? Is that a thing you did, or did we maybe? Okay, I'm seeing a lot of what is happening. Okay, perfect. We'll go through it as if it's the first time you've seen it. All right, so we've got some function here. I'll give you f of x is 2x to the fourth minus 3x cubed plus 7x squared minus 5x plus 9. Okay, I might ask you to find the list of all possible rational roots. And guys, remember, phones away, or I can put them up front for you if that's needed. Okay, key in the directions here. If it just says find the list, just find the list. Don't find the actual solutions. That is so much more work than just finding this list of possible rational roots, okay? When you're finding the list, we'll find it first and then I'll explain what it's really telling you. You are looking for what is called your P over Q list. The P part of this, these are factors of the constant. So right now, this is where P comes from. For us, the 9. And Q is factors of your leading coefficient. So you can ignore all the rest of the numbers in that function. Guys, I know I'm picky with the masks, and I know I remind you guys I don't want to see your nose. The reason is there are now cases among the students and staff here. If there's a case in this classroom, then I get an email, and I have to give them the seating chart. And then they ask me, okay, was anyone not wearing their mask during class? If your mask is below your nose, and I'm reminding you, I have to tell them, hey, these people were not wearing their masks, okay? So. And then it's much more likely that you're going to have to sit out in quarantine and miss school and all of that. So I'm just trying to keep everybody in school and keep everybody safe. I'm not trying to be mean about the masks, okay? I just want to make sure you understand where it's coming from. All right, so back to our P over Q list. So guys, P, the 9 at the end, what are the factors that make up 9? Like what things could you multiply together to get 9? 3 and 3. What else? 1 and 9. What about -3 and -3? -1 and -9? Okay, So the way we list this, we're going to write plus or minus, and this is just like in front of all of them. I'm not going to make you write it with every single number. But I would say the factors are positive or negative 1, 3, and 9. You don't need to list the 3 twice. And then over, what are the factors of 2? 1 and 2. Also negatives, right? Okay. So plus or minus 1 or 2. What we do with this then is make every combination of a fraction we could out of these values. Again, I'm not going to make you write plus or minus in front of each one. Math space, I can't remember if they make you list them individually, like put the plus or minus in front of each one. I think they probably do. But you can just do it out in front for me. So positive or negative, and then just have some sort of structure to how you're doing this. I like to do each numerator over the first denominator, each numerator over the next denominator. I don't care what your plan is, but have a plan. Don't just like willy-nilly make fractions, okay? So I would do 1 over 1, which is 1, 3 over 1 is 3, 9 over 1 is 9, and then each of them over the 2. So I would have 1/2, 3 halves, and 9 halves. And that is your answer. So if I say find the list, that's key. Not too bad. Okay, so what's the point of this? What does this list do? This gives you every possible rational root. So if I had said, hey, solve this polynomial, like find all of the solutions, you could then take these and do synthetic division with each of these until you found ones that worked, until you could remember last class how we would divide and get it down to something we could factor and solve. That's what you would do with these, because if I don't give you a calculator and if I don't tell you what any of the solutions are, that's where you would need to begin. We're not going to do that right now, but that's like the point of this is so that you can do synthetic division with them until you find something that works. Okay? You can see how that would be a much longer process than just making the list of these values. Okay, let's try one more of these just to make sure you guys have it on the list part. All right, let's say f of x is equal to negative 3x cubed plus 5x squared minus 2x plus 6. And again, I just want you to find your P over Q list. All right, guys, so P over Q, again, you'd start with your constant on the end there. So factors of 6. Did you have 1, 2, 3, 6 with a plus or minus in front? Okay. Now it's a negative 3. Does that really change anything? No, instead of -1 and -3, you'd have -1, +3, or +1, -3. It doesn't matter. You still have plus or minus 1 and 3 in front. So your factors, or your possible roots here, you'd have 1, 2, 3, 6. I'd have 1/3, 2/3. Now, 3/3 is 1. Do you think I need to list it again? No. What about 6/3? No. Okay, so that's it. So are we okay on the P over Qs? Makes sense? I know that's quick, but it's not too complicated. Much longer if I make you find your factors with that, but we won't do that right now. All right. Next, we're going to write a polynomial. It's a polynomial function of least degree with real coefficients that has the given solutions. You are given, actually, I'll write x equals 5, -1, and 3i. Okay, so our directions here, write a polynomial function. That means you should have f of x equals something at the end here. Of least degree, that just means the right degree for the number of solutions you've been given. With real coefficients, that means you cannot have any i's left in your answer. You don't have to multiply this out completely, just far enough that there are no i's in your answer, okay? And you have these given solutions. So does anybody remember anything about imaginary solutions? Do you remember how they always come in pairs? Yeah, so if you have one, if you have positive 3i, what else do we know we have? Yeah, so that's also one of your solutions. So the degree of our polynomial should be 4th degree. We have 4 solutions. Okay. The next step here, you don't have to write this every time. I just want to show you where this is coming from. So this really means x equals 5, x equals -1, and then I'm going to write x equals plus or minus 3i. Like, would you agree those are my solutions? Okay. To turn these into factors, you do this automatically when it's just a number. Like, am I right that you'd be like, yeah, x minus 5 is a factor? Okay. That comes from this solution. You're just like working backwards. You're moving the 5 over. So the next one would be x plus 1. Okay. Now, we could move the plus or minus 3i over. I don't want to yet, though, because I really don't want i's in here. Okay? I don't want these imaginary solutions. So what I'm going to do to that one, it's clearly special. It's different than the other two. I'm going to go ahead and square both sides of my equation. Okay? So I'm going to square this x, and I'm going to square that plus or minus 3i. So I now have x squared equals, what do I get on the right side?
-3.
Close. You end up with -9. Yeah, the plus or minus, when you square that, that just means it's going to be positive. The 3 squared is 9, and then we have I squared. Some of you, it sounds like, are remembering I squared equals -1. That's buried somewhere in your brain, right? Yeah, okay. So this is really x squared equals -9, which means x squared plus 9 is the factor that comes from that. Okay? You certainly could have, you don't need to write this part down. You absolutely could have done the factors, you know, x minus 3i, x plus 3i, and multiplied it out. And gone, okay, those cancel, and then we get minus 9i squared. And that's fine. You can get there that way too. It gets more complicated when our imaginary solutions get more complicated. Like that multiplication gets uglier. So that's why I'm showing you like the shorter way to do it. So my actual answer here, my polynomial with real coefficients here would be f of x equals my factors of x minus 5, x plus 1, and x squared plus 9. Okay? On the free response part of your test, that's as far as I would ask you to multiply it out. You certainly could multiply it all the way to x to the 4th and all of those. But I just want you to not have imaginary numbers in your answer. Okay? So let's try another one. All right, your solutions for this one are x equals -2 and 4 minus I. So if 4 minus I is a solution, what's another solution that you know is here?
4 plus I.
Okay, good. And now I'm going to walk through again the process I did on that last one. I know that x equals -2 is easy, and you're fine with that factor of x plus 2. You don't have to write that one out every time. I know you can do that. These imaginary ones, though, this one would be x equals 4 plus or minus I. I don't want to square it yet. I want to move the 4 over, so I have x minus 4 equals plus or minus I. And now I can square both sides of my equation. Okay, so x minus 4, when I square that, what do I get?
X squared minus 8x plus 16.
Good. What do I really have on the right side?
-1.
-1, good. So my factor then would be x squared minus 8x plus 17. Okay, that's the whole thing. So your f of x here is x plus 2, that's the easy one. And then this lovely x squared minus 8x plus 17. Again, there are other ways to multiply that out and find your way to that same answer. If you really like doing, you know, x minus 4 minus I times x minus 4 plus I, and, you know, sure, x squared minus 4x plus xi minus 4x plus 16 minus 4i minus xi plus 4i minus I squared. I think that's more painful than the other way. But if you're like, no, this makes sense, I like this, do it this way, I don't care. Data, expose are gone. You have 16. Plus, like, get to the same spot. It's just whatever makes more sense in your head. I find that to be messy and easy to screw up a sign somewhere. But it's totally up to you. Does it make sense what I'm looking for on those type of questions? Okay with that? Okay. All right. Let's try. Going to have you do one more. You guys try this one. All right, your zeros this time, or your solutions are -5 and 3 minus 2i. When you're ready, check with your neighbor. Okay, guys, lots of people got there. Super common mistake on forgetting to square your 2. So let's just look at it. I know the x plus 5, like that one's easy, right? We don't have to worry about that. And this is really 3 plus or minus 2i. So I can say x equals equals 3 plus or minus 2i. Bring that 3 over. And you guys did a good job squaring the left side there. Have x squared minus 6x plus 9. On the right side, though, don't forget, you got very good at squaring the I, but you have to square the 2 also. So that's really 4i squared, which is minus 4. So when you bring it over, you would have x squared minus 6x plus 13. Okay? All right, so any questions on either how to get there or how far I want you to go into your answer? Are we good on that? Okay. Are you guys doing okay? Are we a little tired today? It's a rough Monday. All right. Different type of question here. You are given f of x is x to the 4th minus 6x cubed plus 20x squared minus 22x minus 13. And 2 minus 3i is a solution of f of x. Find all solutions. All right, guys. Any thoughts on to where you might want to start? You don't have to do the P over Q. It's a good thought. That would help you find any rational roots. But we've given you one solution. What can you do with that 2 minus 3i? What have you done in the past when you like, oh, this is a solution, what do I do? Division. Okay. You have two options here. You can do synthetic division with 2 minus 3i. And if I know 2 minus 3i, what else do I know? Okay, so I know I've got two solutions there. So listen to your choices. You can do synthetic division twice with 2 minus 3i and 2 plus 3i. I will show you that because it's interesting how it works out. It gets ugly and then it gets really nice at the end. Or if I know x equals this 2 plus or minus 3i, could I figure out the factor that came from that? And then could I use long division? Okay. Try it that way. See if you can figure that part out. Remember, bring the 2 over. But I will definitely show you the synthetic division way. It's one of the few times where long division is actually nicer than synthetic. I know, Lauren's very excited. This is a rare day. If you get a remainder of 0, good job. You are very much on the right track. Are we getting to x squared minus 2x minus 1? Okay, what do I do with that? Okay, so set it equal to 0. Does it factor? It doesn't factor. Gosh, it sure looks like it should, but it doesn't. Because if you do -1 and +1, you don't end up with -2. And -1 and -1 doesn't actually give you -1. It does not factor. So now what? No? Do you have any other ways to solve? You can absolutely do the quadratic formula since it is quadratic. You could also complete the square. If you like completing the square. Did you learn completing the square last year? Yeah. Okay, good. You can certainly do that method. I'll go through quadratic formula with you. So opposite of b plus or minus square root b squared minus 4ac all over 2a. So 2 plus or minus the square root of, that'd be 8, right? Which, can we jump right to 2 root 2 over 2? And then you also had your initial solutions of 2 plus or minus 3i. Whew. Okay. How we doing, guys? You're still what?
On division.
Still on division. Let me go back up to the division. So you can see if anything happened there. We'll pause for a minute, make sure everybody can get to the end. Then again, I will do the synthetic division part. It's easy to miss a sign. I almost missed the negative on the 2x cubed right at the beginning. So, yeah. Sure. Walk around. If you're stuck on the division, Let me know, and I'll see if I can find your spot.
Oh. Yeah.
Okay. So that's not the light. We get there? Okay. Oh, yeah, you can. Oh, okay. So this would be just 2 root 2. And then I'll go back down to it because I forgot to simplify. Guys, good point brought up. Yes, we can absolutely simplify this 2 plus or minus 2 root 2 over 2. I can certainly divide all of those by 2. Here it should have just been 1 plus or minus root 2. Minus root 2. There we go. I guess just another second here, and then we'll look at the synthetic division of all of that. Do you guys need me to go back up to the division? All right, guys, let's look. You don't have to write the synthetic division one down. I'll just show you what it looks like. So, same problem. I'll start with dividing by 2 plus 3i. So, yeah, I'm giving myself lots of space here. My coefficients were 1, -6, 20, -22, and -13. Okay, just for the setup here. Okay, so synthetic division, we bring down the 1. Then I multiply, so this is 2 plus 3i. Okay, so this is clearly, it's weird right from the start. So when I add, I have -4 plus 3i. You then have to multiply -4 plus 3i times 2 plus 3i. So you have to, like, off to the side, think about that. Do you see why I said the long division's actually easier on this one? So we'd have what? -8, that'd be 6i, minus 12i, minus 12i, and then that'd be plus 9i squared, so minus 9. So I've actually got, I didn't write minus 6i. So I'd have -17 minus 6i. Okay. And we add, and I have 3 minus 6i. Right? And I get to multiply again. 2 plus 3i times 3 minus 6i. So 6, that'd be minus 12i plus 9i, so what, minus 3i, minus 18i squared, so plus 18, so we have 24 minus 3i. Okay? Add, and I would have 2 minus 3i. Okay, this looks promising. So now I have to multiply again. 2 plus 3i times 2 minus 3i. All right, conjugates, that's helpful. So 4, those would cancel. So minus 9i squared plus 9. Oh, look at that. You two get no remainder at the end. Okay, not real pretty though. But we have the conjugate to divide by as well. So now I'm going to do 2 minus 3i. So I'll bring down my 1 and I'll multiply. Nice, I can add together and I get -2. Multiply. And that would be -4 plus 6i. Lovely. -2 plus 3i. I find it shocking that it like works out so nicely in the end. Like I know it's going to because those are factors of it, but it's weird that it can go from something so ugly to these nice x squared minus 2x minus 1. So you end up in the same spot. So if you really like synthetic division, you could certainly do it that way. And then you still have to solve from there. Either way works. So just be aware of these imaginary solutions and that, yes, you can do long and synthetic division with them. It's just a little messy. Okay, questions on anything? All right. We were going to do a little review game practice stuff with this, but we have about 10 minutes left. Fire drill definitely cut into our time today. So what I'm going to do, let me make the math space available, and then I will pass back your tests while you guys start on that day. So that's the end of notes, okay?